So we're into a new unit, climate, and I told you that it's going to be related to energy sources, and I told you that the two of them are going to be tied together, and we're in the second of those two units, so let's figure it out. Now, I know that climate can be politicized, and I know there's a whole political world around it, and I know that choices that have been made are for and against. We can get into that later if you want, but right now let's just understand the actual science of climate. So the reason we have climate is, go back to that beginning unit that we started with when we learned about control groups. Well, climate's kind of like the control group for weather. To know whether something is weird or not, or unusual or not, or to know if we should be concerned or not, we need to have climate so that we can understand it. If it rains 20 days in a row in North Carolina, that's kind of weird. But if it rains 20 days in a row in the rainforest, that's not weird at all. So it gives us these averages, this baseline, this kind of normal that we can expect and to know if something weird happens. Part of it is going to be where you're at. And the first thing we're going to talk about is if you're near the coast or not, or large bodies of water or not. Because water has a higher specific heat than land, it's going to keep coastal areas more regulated. We're going to see more consistent winds there. The summer's going to get warm and the winter's going to get cold, of course. But we're not going to see these huge extremes in between the two of some other places, especially when we go further inland. The combinations of these things kind of help us kind of even keeled throughout the year. That's going to be a little different when we move inland. So, it's a 3-hour drive to Wilmington or so, maybe a little bit further to the Outer Banks, maybe 5 or 6. But we're not that far away from the ocean compared to, say, Nebraska. Nebraska's in the middle of the U.S. and they're at least a day drive away from any kind of coastal area. So their weather is going to be a completely different thing than ours. Their climate is going to be a completely different thing than ours. And remember, weather and climate are not synonyms. You can't compare the two of them. Yes, weather and climate are related, but they're not the same thing. That's why they're different fields of scientific study. Inland areas have a different set of rules because of the lower specific heat. So they are going to have more extreme summers and more extreme winters because they don't have those coastal areas, that water to regulate them, to keep them kind of consistent throughout the year. The next thing is how far up or how low down on a mountain you are. The further up the mountain we go, we know that the temperature drops. And the further up the mountain we go, we know that the pressure also drops. These are called inverse relationships. When one factor goes up, the other one goes down. Or if you want to think of it as one goes down, the other one goes up. It doesn't matter. They're going opposite directions, and that's what you need to know with inverse relationships. We also know, due to a bunch of testing and taking stats and data and all this kind of stuff, that we can drop between 3 to 5 degrees every 1,000 feet of elevation we gain. And I know that's not metric, and I know I told you we're going to stay with metric, but if I don't give you these things in units that you understand, it's kind of hard for you to conceptualize what those things even mean. So what are some other factors? We talked about how close or how far away from the water we are, and we talked about how far up or how low down a mountain that we are. Well, the next thing is going to be, where are you on the Earth? If you're near the equator, we know, hopefully, remember from astronomy, that the equator gets the most consistent sunlight because of the tilt of the Earth. It's going to stay fairly even throughout the year. But the closer you get to the poles, the North or the South Pole, it's going to be way more extreme. Because of this tilt, it might be really sunny for a long time, but it's never going to get that hot. And it might be really dark for a long time, but it probably will get that cold. But it's not just because it's a cold area already. It's due to this direct or indirect sunlight. The closer to the equator, the more consistent the sunlight, the warmer it's going to stay. This is going to affect climates. So let's combine all of this and figure some things out. Looking at the map that I gave you in your PowerPoint, you can see that the southern hemisphere has a lot more water in it. And because it has a lot more water, and because it has less land, especially compared to the northern hemisphere, you know that it's going to stay more consistent. Well, how do you know that? It's the stuff I just told you. With that much more water, you know that water keeps climates consistent. There you go. So when we look at the climates moving forward, when we get into our different kinds of classification systems, which won't be in this video, so don't worry about that, we can see that the southern hemisphere is going to act a little bit differently than northern hemispheres. what we put that on, different kinds of maps or different kinds of 3D modeling or anything like that, all goes back to the principles of topographic maps and depth charts and things like that. We're not, unfortunately, going to have time to get into any of those things, but there is a term I want you to know as we go along. And it's the first time you're hearing it, but it's not the last that you're going to hear it, and that's called an isoline. And an isoline is a line on a map or a chart or whatever that shows one thing. So an isotherm shows one temperature. An isobar shows one pressure. There are isolines for concentrations of pollutants and all sorts of other things. Contour lines are isolines for elevation. It shows one height or one elevation line. Keep that in mind. We're going to start using those moving forward. Not quite yet, not necessarily on topographic maps, but they're definitely going to be important when we get to weather, which is, of course, related to climate. None of this, though, is possible without ocean currents. And whether you realize it or not, ocean currents and the oceans are a huge, important factor into the worldwide climate, into our climate, into Europe's climate, and to everyone. Without the oceans, which take up so much of the earth, moving all this water around and moving all this different temperature water around, with the warm water starting in the equator area, and the tropics is what we call them, and moving up to the poles, and the cold water being pulled from the poles back down to the tropical areas. Without all this transfer of heat and all this transfer of energy, climate doesn't act the way it should, and climate won't act like that if these things are disrupted. Maybe foreshadowing there. We need to remember, regardless of if it's a surface current or a deep ocean current, that it's driven by differences in density. And we're going to talk about this again later when we get to hydrosphere, and it's important for weather when we talk about air and how that moves. It's all driven by differences in density. Do not think of it as temperature. You might have heard that warm air rises and cold air sinks. No. Less dense air rises and more dense air sinks. The same is true with water. It's all a fluid, if you remember it back from astronomy. Less dense water rises, more dense water sinks. That has nothing to do with the temperature. However, because it's the ocean and it's salty, we also know that salinity affects density. The more salt that's in the water, the higher concentration of salt, the more dense it is. So you can combine all these things around, and you can start to see how these ocean currents work. But why? Why care about all this? Why study it? Why spend time on it? Why get into so many arguments and political fights and bills and agreements and accords? And why care about this? Well, regardless of what you think and regardless of what your background is, science tells us the following things have been affected by changing climate conditions. We know that habitats and ecosystems have been affected. We know that storm systems have been affected. We know that tropical storm systems like hurricanes have been affected. We know that water has been affected. We know that where we can and can't grow crops has been affected. We know that temperatures has been affected. We know that atmospheric makeup has been affected. We know, you get the idea. Whether you like it or not, and whether you want to buy into the political parts of it or not, science is not arguing this. There is no debate for this. It is accepted scientific fact that climate is changing, humans are helping it change, and that it's affecting us every day. Now, you might not care because you think, I'll be dead, I don't care. Well, maybe you should, maybe you shouldn't. That's not for me to tell you what to do, but I am going to tell you that your choices and our choices and the world's choices today are going to affect what it looks like in 10, 20, 50, 100 years, and maybe you won't be here, but someone you know probably will be, and whether you want to leave, that world behind, or whether you'd rather have yours now and, they can deal with it then, we can talk about. But no matter where you fall on that political spectrum, no matter where you fall on that mindset, we know that it's changing. We know that we're responsible for it. So what are we going to do?